Hello, and thank you for viewing my presentation. I'm Joe Von Driska, a senior fisheries scientist with EA Engineering Science and Technology, a public benefit corporation. I've been with the EA for 36 years, and I'm also the operations manager for our office in Deerfield, Illinois, a northern suburb of Chicago. My career is focused primarily on evaluating Clean Water Act Section 360A, thermal discharge, and Section 360B, cooling water withdrawal, impacts by power plants to their source water bodies. Our company conducted the Ohio River Ecological Research Program in 1991, 1992, and from 2000 through 2019. For the last 16 years, this program was managed by EPRI, the Electric Power Research Institute. EPRI is an independent, nonprofit organization that conducts research and scientific investigations for the power industry. I have segregated my presentation into three basic parts. First, I'll provide a bit of historic background in terms of the start of the program, the study sites, about that have been sampled, and drilling down into the adult juvenile fish sampling that was the mainstay of the program. Then I'll discuss the study design and sampling methods used in recent years, and conclude my presentation with examples of how the program's data were used to address a variety of research needs and regulatory requirements. 2019 represented the 50th consecutive but final year of this collaborative research program. What was the Ohio River Ecological Research Program? The best description is from an Electric Power Research Institute technical brief, and I quote, "The Ohio River Ecological Research Program is the world's largest and longest maintained freshwater database on the potential effects of power plant water withdrawals and thermal discharges. The research program yielded invaluable information for power plants and local communities while documenting important ecological changes in one of the nation's most important rivers. This collaborative study, conducted adjacent to most of the 27 river-cooled power plants that once operated along the nearly 1,000-mile Ohio River, enabled electric power companies to show that impingement and entrainment of fish and shellfish resulting from water withdrawals for cooling and associated discharge of heated water did not significantly impact fish populations and communities. Visit EPRI.com, search for ORERP to download free reports and technical briefs. Although the program was not officially named the Ohio River Ecological Research Program until 1977, the collaborative effort began in 1970 when the Ohio Electric Utility Institute, represented by these 8 companies, along with Louisville Gas and Electric and Kentucky Utilities, sponsored the first study. With the exception of Dayton Power and Light, the remaining 9 companies are better known today as either American Electric Power, Dynegy, First Energy, LG&E and KU Energy, or Ohio Valley Electric. The first study spanned 15 months, July 1970 to September 1971, and its objective was to determine the actual effects of power plant thermal discharges on the Ohio River and its plant and animal inhabitants. This was the primary objective of the program throughout its 50-year history. The first 4 power plants studied were Samus, Tiger Creek, Beckjord, and Cane Run. This study focused on phytoplankton, zooplankton, macroinvertebrates, primary productivity, ichthyoplankton, and adult juvenile fish. 22 power plants participated in the program during its 50-year history. 5 of them participated for 30 or more years. Samus and Tiger Creek, 2 of the founding plants, each participated for 43 years. Tanner's Creek participated for 42 consecutive years from 1972 to 2013, prior to being retired in 2015. Cardinal Plant participated during 41 of the last 42 years, and one of the other founding plants, Beckjord, had participated for 30 years, but it was also retired in 2015. After these 5 plants, it's Kifty Creek at 24 years, and the Shawnee and Cane Run plants at 18 years each. The remaining 14 plants have participated during 11 or fewer years. Of these 22 plants, 12 have been retired. The 22 power plants spanned approximately 900 river miles from the Samus plant, located about 50 miles downstream from Pittsburgh, to the Shawnee plant, located about 40 miles upstream from the mouth of the river. The 22 facilities are, or were, located in 13 of the 19 Ohio River pools. The annual number of participating facilities ranged from 3 to 7 from 1970 through 2003, with typically 4 or 5 annual participants. Participation increased abruptly in 2004 to 13 plants and to 17 plants in 2005. Increases in these 2 years were due to the remanded Phase 2 316B rule. Since 2005, participation has declined due to retirements, with 5 or 6 facilities participating in each of the last 3 years. In-river fish sampling was the foundation of the program for 49 consecutive years. A couple of special fish studies were conducted concurrently. Fish engine growth studies were conducted in 3 years, 2 years of which were conducted to provide input for a population model. Fish tissue collections were made during 6 years to support EPRI's and AEP's research of mercury and selenium in the Ohio River. Habitat at each electrofishing and seining location was evaluated during 28 years, and 136 fish species were collected to date. Other biota sampled during the program consisted of ichthyoplankton in 22 years, including a recent entrainment characterization study that was conducted at 7 plants in 2015 and 2016, and macroinvertebrates during 20 years, zooplankton and phytoplankton each for 8 years, field surveys for mussels during 2 years, as well as a mussel literature review in 2011. The program consistently used a multi-gear approach, and at the end of the 2019 sampling season, about 18,700 gear efforts were expended. Electrofishing was the primary method used and conducted annually for 48 years, with about 6,400 efforts. There were 2 major changes in electrofishing methodology. The first was in 1981, then when there was a switch from AC to DC, an effort was increased and standardized to 30 minutes. The second was in 1991, when there was a switch from daytime to nighttime electrofishing, and effort was based on distance, 500 meters per location, rather than time. This change was based on Ohio EPA's methodology for sampling on large rivers, as well as research that had been conducted on the Ohio River. This is also the same basic methodology used by Rosenko, the Ohio River Valley Water Sanitation Commission. Seining was conducted for 42 years, yielding about 5,000 gear efforts. Gill netting, trawling, and hoop netting were conducted off and on from 1971 through the early 1990s. They were dropped from the program because they were quite selective in terms of the species and size of the fish they collected. As such, electrofishing and seining were the 2 gears used since 1995. The program's basic study design was consistent during the last 29 years, in that there were 3 locations upstream and 3 locations downstream of each plant. Each location was sampled in June, August, and October by electrofishing at night and seining during the day, depending upon river conditions. Targeted river conditions were stage levels within 3 feet of normal pool and water clarity in excess of 300 millimeters. Also, note that a special winter study was conducted from 2007 through 2009. Water temperature, dissolved oxygen, specific conductance, and secondary depth were measured at each sampling location. Habitat was evaluated once each year, typically in August. Seining locations were evaluated using Ohio EPA's Qualitative Habitat Evaluation Index, or the QHEI. Electrofishing locations were evaluated using Rosenko's method, which consists of a 66-point grid within each electrofishing zone where substrate is characterized and depth is measured. River stage and flow data were obtained from the gauging station nearest to each plant and summarized in the annual reports as depicted in this graph. 9 electrofishing community measures were calculated for each annual study since 2004. These measures were numeric CPE in terms of number per kilometer, biomass CPE in terms of kilograms per kilometer, species richness, diversity, Ohio EPA's modified index of well-being, and the original and modified versions of the Ohio River Fish Index, which is the index of biointegrity developed specifically for the Ohio River by Rosenko. Numeric CPE, diversity, and the modified index of well-being were also calculated without shad and emerald shiner because these eruptive species routinely skewed those results. Therefore, based on study design, 18 values per measure each year were statistically analyzed for temporal and spatial differences at each participating facility. To this point, I have discussed why the program was conducted, who participated and when, the biota studied, and how data were collected and analyzed in recent years. The remainder of my presentation will provide examples of how the program's data were used. The data were primarily used to address the program's primary objective with respect to 316A, potential thermal impacts on an annual, long-term, NPDES-specific, pool-specific, or river-wide basis. Data were used to support Section 360B, intake NPDES requirements such as source water biological baseline characterization. They're also used to evaluate long-term trends at a given plant for community measures and for individual species, as well as showing how the community measures and the abundance of individual species varied on a longitudinal basis among plants. In terms of addressing 316A issues on an annual basis, this slide provides a narrative summary of the Spatial Anova tests performed on the 9 electrofishing community measures for 5 participating plants in 2019. Of the 45 comparisons, 8 exhibited significant differences due to higher upstream values. At 3 plants, none of the measures were significantly higher upstream. At 1 other plant, 3 measures were significantly higher upstream. And at the remaining plant, 5 of the 9 measures were significantly higher upstream compared to downstream. Overall, thermal avoidance in 2019 was minimal. Now, if this were your results and you only have 1 year of data, discussions with the regulatory community may be difficult in terms of addressing long-term effects. However, if you have a long-term database like this program provided for its participants, it is much easier to address long-term effects. For example, this table summarizes 28 years of annual Anova results from one of the long-term plants for 3 community measures: species richness, the Modified Index of Well-Being, or IWB MOD, the Ohio River Fish Index, or ORPHIN, from 1991 through 2010, and the Modified Ohio River Fish Index, or MORPHIN, from 2011 through 2019. This column shows the number of years for which values were significantly higher upstream. 4 or fewer years for the first 19 years, but 3 to 6 of the last 9 years. Given that this facility operated in a similar or reduced fashion during the last 9 years compared to the first 19 years, what changed during the last 9 years compared to the previous 19 years? I believe the more frequent significant differences over the past 9 years is due to the adverse effects of hydrilla. In this example, the long-term data set allowed an examination of alternate causes of the observed spatial differences. An example of how the program's data were used to address pool-specific issues occurred in 2004, when Arsenko's orphan scores showed non-attainment in 4 pools and considered listing them as impaired under 305B. However, this program's data show that nearly all upper river locations were in attainment in August 2004, and the general lack of attainment in the middle river was due to extremely high flows, including a 50-year flood that occurred in September. Ultimately, the 4 pools were not listed as impaired. However, if Sanko did not have another data set to evaluate at that time, it is likely that the 4 pools would have been listed as impaired. This slide shows a couple of images depicting the flood in September 2004. On the left is Belfield Lock and Dam, which was totally inundated by floodwater. On the right is a graph showing the tailwater stage at the Pike Island Lock and Dam. Here the river stage rose about 25 feet in 24 hours and was the 3rd highest crest among the past 58 years. We sampled about a month after this flood and essentially found non-attainment of orphan scores throughout the river, showing that it took a fair amount of time for the fish communities to recover. Climate change is evident as 5 of the last highest crests for this gauging station have occurred during the past 13 years. For me, one of the most important milestones of the program occurred in 1999, when it was decided to create a population model which required species-specific abundance and lake frequency data. At that moment in time, there was no electronic database. As such, 22 years of the program's hard copy electrofishing appendices were manually entered and proofed, and a database created in a manner to allow the seamless merging of Recycle's data. The model also required site and species-specific age and growth data for the 7 species that were proposed for modeling. Those data were collected concurrently with the 2000 and 2001 annual programs and represented the first of its kind information for 5 species from the Ohio River. Ultimately, the combined electrofishing database that was created during this effort has allowed the program to evolve over time in terms of having the ability to calculate new community measures such as the orphan or morphin, compile and summarize data to address the 316A issues just discussed, as well as examine long-term and longitudinal trends for community measures in individual species or groups of species. An example of plant-specific long-term trends are presented here. This graph compares annual mean electrofishing species richness, modified index of well-being, and orphan values from 1991 through 2019 at the Cardinal plant, which is in the upper river. Generally, these 3 measures exhibited an overall decline throughout the 1990s, followed by an overall increase to 2011. However, values for each measure were erratic among the last 8 years. This variability appears to be associated with the density of hydrilla. The dips in 2015 were, however, due to the record high monthly river flows in July of that year, which depressed community measures in both August and October. Arsenko uses average morphin scores to assist with determining the overall biological condition of Ohio River pools. Morphin scores are assigned condition ratings that range from very poor to excellent. Morphin scores greater than or equal to 20 are considered to be an attainment of the aquatic life use designation. This graph presents mean August-October morphin scores from 2011 to 2019 for each participating plant. The first series is from 2011, all in attainment. 2012, all in attainment. 2013, borderline attainment at the 2 upstream plants due to dense beds of hydrilla, but all other study sites in attainment. 2014, 2015, 2016, and 2017, all study areas in attainment. In 2018 and 2019, all study areas except Cardinal were in attainment. Longitudinally, the upper plants tended to cluster in the fair range, whereas the middle and lower plants typically clustered in the good to very good range. What is the value of this program? Provided data addressed 316A, and River data supported certain aspects of Section 316B, conducted impingement and trainment studies at up to 15 facilities to address 316B, supplied in-river data that tracked long-term trends at the species and community levels, afforded the ability to examine longitudinal trends throughout the river, and yielded invaluable information for power plants as well as regulatory resource agencies, while documenting important ecological changes in one of the nation's most important rivers. In closing, I'd like to thank these sponsors for their participation and support. Also, thank you for viewing, and please email me any questions.